You're listening to DTFHN for May 6, 2026. I'm your structurally unsound host, Jack Hacksman. We are your daily tech feed for hacker news, a website where mass replying skill issue is considered community engagement. Today's a day for watching people build ladders and watching corporations pull them up behind them. Let's get into it. In 1918, Microsoft released something called Passport. The idea was simple. One login, one identity, one payment method, and any service on the internet could provision itself around you. The web recoiled, privacy advocates screamed, regulators circled, and the whole thing collapsed under the weight of one uncomfortable question. Why should Microsoft be the identity layer for the entire internet? 27 years later, Cloudflare and Stripe just built the same thing. Except this time, the customer isn't a person. It's an agent. Here's the play. You tell your coding agent to build something and deploy it. The agent calls Stripe, discovers Cloudflare is in the catalog, provisions a Cloudflare account on your behalf, obtains an API token, buys a domain, sets up billing through Stripe's payment tokenization, and deploys your app to production. You, the human, approve terms of service and maybe add a payment method. That's it. Zero to production with no dashboard, no copy-pasting tokens, no configuration. Now let me play devil's advocate for a moment. This is actually impressive engineering. The protocol layers OAuth, OIDC, and payment tokenization into a discovery authorization payment pipeline that genuinely removes friction. If you're a developer who's ever spent 45 minutes fumbling through DNS settings and API key management just to ship a side project, this solves a real problem. Credit where it's due, but here's the comedy. The entire internet spent 2 decades building CAPTCHAs. Prove you're not a robot. Cloudflare itself is arguably the world's largest CAPTCHA provider, and now the pitch is, if you are a robot, write this way. Here's your account, here's your domain. What else can we provision for you? One of the Hacker News comments nailed it perfectly. The raccoons learned how to open the cooler. The deeper issue isn't capability. It's architecture. This is a closed discovery protocol. Stripe decides which providers appear in the catalog. Cloudflare decides what agents can provision. The agent discovers services through a curated marketplace, not an open registry. We've been here before. App stores, payment processors, walled gardens that start as convenience and calcify into control. The protocol itself is interesting. And if it were an open standard that any provider could implement and any agent could query without gatekeepers, that would be genuinely exciting. Instead, it's 2 large companies building a bilateral integration and calling it a platform. The $100,000 in credits for Stripe Atlas startups is the tell. This is customer acquisition infrastructure dressed up as developer tooling. What I actually want is the open version of this. An agent that can discover any hosting provider, compare pricing, negotiate terms, and deploy wherever serves the user best. That's the protocol worth building. What we got instead is a very slick way to make sure the agent always picks Cloudflare. The raccoons can open the cooler now. The question is, who stocked it? Moving on. Every laptop trackpad is a compromise. The mechanical ones use a hinged plate. Pivot at the top, click at the bottom, which means the top third of the surface is essentially dead. You can tap it, but you can't click it. Apple solved this years ago with their Force Touch trackpad, a solid piece of glass. Strain gauges to detect pressure, and a linear actuator to fake the sensation of a click. It was genuinely brilliant engineering. It was also locked inside a machine that decides what software you're allowed to run. Star Labs just shipped the StarFighter 16-inch. And the spec that matters most isn't the CPU or the RAM. It's the trackpad. A solid-state haptic trackpad on a Linux-first machine. Glass surface, oleophobic coating. Full area clickability. Simulated click, feedback through vibration. This is the kind of hardware refinement that Linux laptops have been missing for a decade. The software was always there. The kernel support was always there. What was missing was a manufacturer willing to invest in input hardware that doesn't feel like a concession. The warranty language is worth reading. Star Labs explicitly permits you to open the machine, replace parts, install upgrades, and run any operating system without voiding coverage. That sentence would be unremarkable if the industry hadn't spent 20 years making it radical. Framework gets deserved attention for repairability, but Star Labs is doing something subtly different. They're building a polished, opinionated machine and then handing you the keys anyway. The comments surface real concerns. The product page shows a motherboard image with socketed RAM, but the actual configuration uses soldered LPDDR5X. That's a legitimate transparency problem, and Star Labs should fix the imagery. There's also an EU compliance issue. Mandatory charger bundling and a 1-year warranty where 2 is the legal minimum in several member states. These are growing pains, not disqualifying flaws, but they're the kind of details that erode trust if left unaddressed. The broader context matters. Framework, Star Labs, System 76, Tuxedo. There's now a real ecosystem of companies building machines where the owner is actually the owner. The trackpad is a symbol of something larger. For years, the argument against Linux hardware was that it couldn't match the fit and finish of closed ecosystems. That argument is running out of evidence. The tools exist, the glass is cut, the haptics work, and nobody's asking permission. 3 stories in, and we're already jumping species. Next up, someone taught a robot dog some very new tricks. One commenter on Hacker News did the math. 3 degrees of freedom per leg, 4 legs, 12 motors and controllers total, and the whole bill of materials comes in under $1,000. The motors are $18 each. $18 for a brushless outrunner that, after rewinding, delivers enough torque to make a robot dog jump. Run that number forward a few years and ask yourself what a quadruped costs when those motors hit $9. Then, 5. Amusa's CARA 2.0 is a robot dog built with a coaxial 5-bar linkage. A leg architecture that most quadruped projects avoid because it's harder to design. Musa chose it precisely because it distributes load across the links more evenly than a standard leg, and because it pairs naturally with capstan drives for a compact 3 degree of freedom package. Each leg weighs 1.47 kilograms. The feet are double yellow dot squash ball. The firmest, least bouncy rated. The same ones MIT used on the Mini Cheetah. What deserves a serious look here is the engineering philosophy underneath the project. Musa asks a question that sounds trivial but reshapes everything downstream. Why use 4 screws when 2 will hold? He extends this to bearings, to bracing, to link ratios. Every component earns its place or gets cut. The team even investigated whether making all 4 legs identical would simplify assembly. It did, until it didn't, and Musa documents that failure openly. He walks through the inverse kinematics derivations on his website and demystifies them. 8th grade geometry. Triangles. That's it. Any complex robot structure decomposes into triangles. And once you see that, the math is tedious, but never mysterious. The comments reflect something important. Multiple people flag that the website itself, not the YouTube channel, the actual project documentation, is the real contribution. One commenter calls it spectacular as a reference. Another notes the mechanical simplicity feels optimized for maintainability rather than demos. This distinction matters. A demo-optimized robot impresses a conference audience. A maintainability-optimized robot gets rebuilt by a student in Lagos or Bangalore with access to a 3D printer and $18 motors. Everything about CARA 2.0 is published. The kinematics, the design rationale, the failures, the squash ball selection criteria. Musa isn't building a product. He's building a ladder and leaving it where people can reach it. The tools exist. The geometry is 8th grade, and a robot dog that jumps costs less than a flagship smartphone. We talked about cutting the cord from cloud dependencies. Pause. Now let's cut the power cord too. A flat metal washer with notches cut into its edge. That's it. You flick it, it rings at a specific ultrasonic frequency, and a microphone picks up which tag just got activated. No battery, no chip, no radio, no power source of any kind in the sensor itself. Researchers at Georgia Tech designed these passive acoustic tags where the geometry of the cutouts determines the resonance frequency. Each pattern of notches produces a unique, ultrasonic fingerprint above 20 kilohertz, completely inaudible to humans. Their simulation tool identified nearly 1,300 distinct designs, each ringing at its own frequency. They tested 15 and hit north of 92% accuracy, even in realistic deployments. The engineering elegance here deserves real appreciation. Bolay Dung's team in aerospace engineering used vibration and wave physics to model exactly how the shape of a piece of metal determines its resonance. This is the kind of work where deep domain expertise in one field, acoustic metamaterials, gets crossbred with robotics and computing to produce something nobody in any single discipline would have built alone. The tag doesn't compute anything. It doesn't store anything. It just exists as a specific shape, and physics does the rest. Now run this forward. Stick one on a faucet. It rings when you turn the handle. Stick one on a pill bottle cap. It rings when grandma opens her medication. Stick one on a weight rack. It counts your reps. The viral Instagram video, over 1.5 million views, generated exactly the response you'd hope for. People in archiving proposed using them to track which boxes get pulled from shelves. Waste management folks want to tag thousands of recycling bins. The crowd is designing the product before the product exists. The honest critique is fair. You still need a powered microphone and processing somewhere. This isn't truly infrastructure free. It just moves the infrastructure, but that's actually the right trade-off. Centralize the expensive powered hardware in one place. Distribute the cheap passive tags everywhere. One microphone serves hundreds of stamped metal washers that cost pennies and last forever because there's nothing in them to degrade. The research is published out of Georgia Tech. The simulation tools, the design methodology, the acoustic fingerprinting pipeline. Somebody with a laser cutter and a microcontroller could start building on this tomorrow. The shape is the sensor. The physics is the power source. And 1,300 unique designs means 1,300 problems waiting for someone to match them to a solution. We talked earlier about making the invisible visible. Here's someone who did exactly that. Pause with GitHub's own contribution graph. Let me work with what we have from the title and comments to write this segment. The project, Red Squares, visualizes GitHub outages as a contribution graph, turning GitHub's iconic green squares, the activity heat map on your profile, into red squares that represent downtime instead of commits. The HN comment asks whether weekend sparsity is load-based or employee-based. Here's the script. What does a platform's reliability look like when you map it the same way the platform maps your productivity. There's a metaphor from ecology called indicator species. You don't measure the health of a river by testing every molecule of water. You count the mayflies. If the mayflies are thriving, the river is clean. If they're gone, something is wrong upstream. The organism becomes a proxy for the entire system. GitHub has its own indicator species. That contribution graph, the grid of green squares on every developer's profile, it's become weirdly totemic. People optimize for it. Hiring managers glance at it. It's turned into a crude fitness signal for an entire profession, which is already a little absurd, but set that aside. Someone named Cham built red squares, which takes that same visual language and turns it back on GitHub itself. Every time GitHub has an outage, it gets logged as a red square on a contribution-style heat map. The platform that gamified your uptime now has its own uptime gamified. The river is being measured by its own mayflies. And the pattern is genuinely interesting. One commenter did the obvious double take. Weekends are sparser. Fewer red squares on Saturdays and Sundays. Is that because load drops when developers aren't pushing code? Is it because GitHub's own engineers aren't shipping changes that break things? Probably both, which tells you something about the relationship between activity and fragility. The system is most likely to fail when it's most heavily used and most actively changed. Reliability isn't a fixed property. It's a function of pressure. The whole thing is a small project, a single-page visualization. But there's a reason it resonates. GitHub is infrastructure now. It's the substrate under millions of projects. CI pipelines, deployments. When it goes down, entire workflows freeze. And yet, there's no official contribution graph for GitHub's own reliability. No public heat map where you can watch the pattern emerge over months and years. Chime just built the accountability dashboard that probably should have existed already. The beautiful irony is the format. GitHub taught an entire generation of developers to perform consistency through little colored squares. Now those squares are the unit of measurement for GitHub's own inconsistency. You build the scoreboard, eventually someone points it at you. But what happens when the accountability lens turns to something truly unexpected? There's like whether AI can actually knit. 8 people, 3,000 episodes a week. That ratio tells you everything you need to know before a single word of content plays. Kate Davies, a knitwear designer and historian whose work sits at the intersection of craft, material science, and cultural memory, listen to one of these AI-generated knitting podcasts so you don't have to. She invokes Harry Frankfurt's philosophical framework. And Frankfurt's distinction matters here. A lie respects truth enough to deliberately invert it. Bullshit doesn't even get that far. Bullshit is indifferent to whether things are true or false. It performs the shape of knowledge with nothing inside. The company is Inception.ai, founded by a former Wondery executive after Amazon dissolved Wondery in 2025, cutting 110 jobs. The pivot is worth naming plainly, from employing humans to make things worth hearing, to employing 8 people to flood the zone with things no one checks. Their head of product asked about editorial oversight, said the quiet part out loud. Topics like gardening, knitting, cooking, quote, these things we can afford to be wrong about. Pull that thread. What she's actually saying is, we can afford to be wrong because we don't respect the audience enough to care. Knitting has a 7,000-year material history. It involves structural engineering at the fiber level. Tension, gauge, the physics of how twisted loops distribute force across a fabric. Getting a stitch pattern wrong isn't low stakes to the person whose sweater unravels. Getting the history wrong isn't low stakes to the cultures whose textile traditions carry actual meaning. This maps to something we've seen before. In 2009, content farms like Demand Media hired thousands of freelancers to produce SEO-optimized articles on every conceivable topic. The writing was technically human, but editorially hollow. Generated to capture search traffic, not to inform anyone. Google's Panda update in 2011 eventually crushed those sites in rankings. The ecosystem fought back against slop once already. The difference now is volume. 3,000 episodes a week from 8 people, 750,000 downloads a month. And the question one commenter raised is the right one. Are those downloads even organic, or is the audience itself partly synthetic? Davis frames this as a craft issue, and she's right, but it's also an architecture issue. When the tools to generate are open and the cost of publishing approaches zero, the filter has to come from somewhere. The answer isn't less technology. The answer is better signal. Human curation, trusted sources. The kind of deep knowledge that 8 people running 3,000 episodes a week will never, ever have time to build. Moving on. I once mass-migrated a fleet of domains to a new registrar and fat-fingered a single DS record. 1 domain. 30 minutes of downtime. I still remember the Slack messages. Now multiply that by every single .d domain on the internet, and you have Monday night in Frankfurt. DNSSEC, the registry for Germany's entire country code top-level domain, pushed something that resulted in malformed RR6 signatures across their DNSSEC chain. The technical details matter here. DNS itself was fine. The name servers were up. The zone data was correct. But every validating resolver on the planet looked at the cryptographic signatures, saw they didn't check out, and did exactly what DNSSEC tells them to do. Refused to answer. ICR Evasfail. Every dotted domain dark. One commenter put it perfectly. We took DNS, this beautifully decentralized system that has survived decades of abuse, and bolted on a centralized certificate layer with a single point of failure. DNSSEC was supposed to be the trust anchor. Instead, it became the kill switch. Cloudflare's response is instructive. They disabled DNSSEC validation entirely on 1.1.1 to restore reachability for their users, which means, for a window on Monday night, the security layer designed to prevent DNS spoofing was actively turned off for one of the world's largest resolvers. The cure and the disease, trading places. The comedy here is architectural. DNSSEC's entire value proposition is that you can cryptographically verify DNS responses end-to-end, but the operational reality is that a single registry mistake can take down an entire country's namespace, and the only fast remediation is to stop checking signatures. Which puts you back exactly where you started, minus the trust. This is a bootstrapism problem in disguise. DNS works because it's distributed. Anyone can run a resolver. Anyone can register a domain. The system scales because no single entity has to be perfect. DNSSEC reintroduced exactly the dependency it was supposed to eliminate. One organization, one signing key, one bad evening, 17 million domains. The DNSSEC team resolved it within hours. Credit where it's due, but the lesson isn't about DNSSEC's operational practices. The lesson is that security architectures which concentrate failure modes will eventually exercise those failure modes. And when they do, the fallback is always the same. Turn off the security and go back to trusting the network, which, for better or worse, is what we were doing anyway. Let's shift gears completely. Sometimes the best engineering stories aren't about what's new, Pause, they're about what's ancient. 10 years is a long time to spend on a binary from 1.9.8. The reasonable case against this work writes itself. Ultima Online shipped nearly 3 decades ago. The MMO genre moved on. The server architecture is obsolete. 5,000 functions hand-translated from MSVC x86 into portable C99, each one verified instruction by instruction against the original binary. For a game demo, the pragmatist says, "This is pure nostalgia, an extraordinary investment of skill applied to something that no longer matters." The pragmatist is wrong, and the reason is precise. When Origin Systems compiled uodemo.exe on September 2, 1998, they accidentally shipped their production server code. The actual codebase running live Ultima Online bundled into a Windows demo binary with a few features stubbed out. That binary is the only public artifact of one of the first commercially successful MMO server architectures ever built. Without this work, it disappears. Not theoretically, literally. Binary rot, OS incompatibility, institutional memory loss. The company is gone. The Solaris machines are gone. The source code is gone. Here is the question nobody in the games industry wants to sit with. How much server architecture from the last 30 years of online gaming is already unrecoverable? How many design decisions, failure modes, and working solutions are locked inside binaries that nobody will ever decompile? Draxanar found the famous ecology system still in the code. The one Origin publicly said they removed because players kept killing all the animals. The functions were intact, just unreachable. No live call site. The spawn system, the decay system, same story. Production code, shipped accidentally, preserved by a demo that nobody at Origin thought anyone would ever look inside. The class hierarchy alone is a document of how engineers in 1.9 and 9T containers thought about virtual worlds. So in a T to C, resource entity to say container, to C mobile to C player. Virtual dispatch through readable slots. This is primary source material for the history of network software. The entire reconstruction is on GitHub. Portable C99. Every fix tagged against the original binary so you can see exactly what changed. The tools for manipulating the server data formats are included. The map data for the full world reconstructed. One person, 10 years, and now anyone can read how a 1998 MMO server actually worked. The source is open. The knowledge compounds. That is how preservation is supposed to function. So, what happens when you take that same obsessive engineering energy and point it at making AI inference faster? In Usami Dev, the team building the Pentium Pro made a bet that changed processor design forever. They called it speculative execution. The CPU would guess which branch a program would take, start computing the result before it knew if the guess was right, and throw away the work if it was wrong. The gamble paid off. Modern processors execute instructions out of order, speculatively, constantly. And the performance gains compound across every workload. The insight was simple. Idle hardware is wasted hardware. If you have compute sitting there doing nothing, use it to place bets on the future. 30 years later, the same insight arrives for language models. Google's Gemma team just shipped multi-token prediction drafters alongside Gemma 4, and the mechanism is a direct descendant of that same philosophy. Standard LLM inference is memory bandwidth bound. The GPU spends most of its time shuttling billions of parameters from VRAM to compute units to produce a single token. The arithmetic units sit idle while the memory bus works. Speculative decoding changes the equation. A small, fast drafter model proposes several tokens at once. The full model verifies them in a single forward pass. If the drafts are accepted, and for predictable sequences they usually are, you get multiple tokens for the cost of one verification step. Faster inference, zero quality degradation. The output is mathematically identical to what the target model would have produced alone. What matters here is the architecture of access. These drafters ship as open-weight models. Gemma 4 itself is open-weight. The technique, speculative decoding, was published by Google researchers as open research. The entire stack, the theory, the models, the drafter weights, is available to anyone with a GPU. One commenter noted that support is already being added to llama.cpp for similar models. The community builds on what it can touch. Google's doing something strategically interesting, while other frontier labs chase benchmark supremacy behind closed APIs. This team is optimizing inference efficiency and releasing the results. Performance per watt, performance per dollar. Performance on the hardware people actually own. That is how open source wins. By making the best tools run where people already are. Now, what happens when a platform decides openness is optional? YouTube, let's talk about your RSS feeds. Pause, because they're broken. RSS is one of the oldest open protocols on the web, and it solves a problem so elegantly that it threatens every engagement-driven business model ever built. You subscribe to what you want. You read it when you want. No algorithm decides what you see. No platform gets to insert itself between you and the creator. That's it. That's the whole thing. And YouTube still supports it. Technically. The way a landlord technically supports a tenant, by leaving the heat on at 55 degrees. The feeds break without warning. They vanish for days, sometimes weeks. When they come back, nobody explains what happened. The URLs themselves are these cryptic strings of channel ID, that triptych, that look like someone mashed a keyboard. No human-readable slugs, no discoverable links on the channel page. No subscribe via RSS button anywhere in the interface. You have to know the feed exists, then manually construct the URL yourself. Compare that to the early web, when sites wore their RSS icons, like a badge of honor. Then there's the charts problem. YouTube started injecting short-form vertical video into RSS feeds alongside the long-form content people actually subscribed for. The community response has been telling. People are writing scripts that check each video ID against the shorts endpoint to filter them out. One request per video, just to undo a decision YouTube made for them. That's users building tools to restore functionality a platform deliberately degraded. Here's what makes this worth paying attention to. RSS is federated infrastructure. It's an open protocol that no single company controls. Every time a platform makes its feeds worse, it's not a technical limitation. It's a business decision to keep you inside the walled garden. The feed exists. The protocol works. The choice to hide it is architectural, and architecture reveals priorities. The feeds still work. People are still building readers, writing filters, maintaining the plumbing. The open web doesn't need permission to keep running. This has been your daily tech feed for Hacker News for May 6, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3 TTS. not affiliated with Hacker News or Y Combinator. Now go build something with the tools you already have. We'll see you back here tomorrow.